examples of transverse wave. Now our next topic is actually the longitudinal wave, as I already mentioned that. In this type of wave motion, the particles of the medium execute oscillations uh, about its position of equilibrium in the direction uh, of wave travel. That means both the direction of waves and the particle movement is in the same direction, as you see in my slide. That here as motion of spring is actually the longitudinal wave. And another example of this type of wave is sound waves in air. Okay, at the longitudinal wave, because particle of the medium through which the sound is transported vibrated parallel to the direction of the sound wave. Okay, so these are the example of longitudinal wave. We have another wave of surface wave. In this types, the particle travels in circular motion. Okay, so if the particle moves in a circular motion, so we call this types of waves of surface waves. These waves usually occur at interfaces, waves in the ocean and ripple in the cup of water are example of such waves. আপনারা আপনারা যদি ওই যে একটা একদম যদি একটা বেসিক এক্সাম্পল দেওয়া হয়, আপনারা যদি এক বালতি পানি নেন, তারপরে ওটাকে জাস্ট রোটেট করান পানিটাকে, তাহলে যেই সার্কুলার মোশনটা তৈরি হবে, অথবা সাইক্লোন টাইপ, যখন সাইক্লোন বা ডিজাস্টার হয়, তখন আমাদের ওশানে যে মোশনটা হয় সার্কুলার মোশন, সেই টাইপের মোশনটাকে আমরা কি মোশন বলবো? অ্যাবাউট সারফেস ওয়েভস। ওকে, and our important for your exam, so keep your concentration here. Okay, students, can you hear me?
Yes, sir.
Students, are you there? Okay, so please give response. আচ্ছা, আপনাদের তো আজকে এক্সাম ছিল, আপনাদের এক্সাম কেমন হয়েছে?
স্যার অনেক ভালো হয়েছে।
আলহামদুলিল্লাহ স্যার।
Okay, I think most of you will get full marks, right?
স্যার ওটা আপনার উপর নির্ভর করতেছে।
আমার উপরে তো কিছু নির্ভর করছে না, আপনারা যা লিখেছেন সেটার উপরে নির্ভর করছে। আমার উপরে নির্ভর করবে বলেন? আমি তো কোশ্চেন করেছি, আপনারা যদি খাতায় লিখে থাকেন then you will get full marks, otherwise not. Okay,
yes sir.
So কারো কোনো প্রবলেম হয়েছিল এক্সামে কোন কোশ্চেন? সবাই কি সব কোশ্চেন পেরেছেন?
জি স্যার।
Yes sir. Students, okay, so this is very good if you
শুধু সাবমিট করার সময় কি
answer
দিছিল আর কোনো সমস্যা হয় না?
right answer, then you will get. Okay, আমি আপনার অথবা আমি আপনাদের খাতাগুলো দুই একদিনের so let's start again. As we discussed about that progressive wave is really important for your final exams, so give your concentration now again. So what is actually the progressive wave? A progressive wave is defined as the continuous transfer of perpendicular state from one part of the medium to another by similar movements performed successively conjugated particle of the medium. So this is actually the definition of progressive wave. Okay, and there is for a progressive wave, energy is transferred from the source and propagated outwards. So this is the condition of progress. কি করব আমরা যখন সাম করব দুইটা ওয়েভের, বাট they are directly opposite, তাদের ডিরেকশনটা কি থাকবে, অপোজিট ডিরেকশনে থাকবে। সো আমি যদি ড্র করি, if I draw these things in the board, okay, now আমরা আমাদের now let this is a wave and you have another wave like this. Okay, now let's say that this is one, and let's say that this is another one. Okay, so if you sum together, if you sum this together, you will get a resultant wave, and the resultant wave will be like 1 plus 1 2, so your amplitude will be 2. Okay, so this is the result. But if all these things, if I omit all these things, now if I draw again, if you have a wave like this and you have another wave like this fashion, and if you add this together, and you will get the resultant wave. Resultant wave ta ki hobe bolte paren, this is +1 and this will be what, -1. So
Zero.
this is +1, this is -1, so 0. So exactly যদি identical দুইটা wave but totally different opposite phase এ থাকে, তাহলে যদি আমরা resultant wave নেই, we will get the 0. So আমরা কিছুই পাবো না। বাট এটা যদি এরকম হতো, but if you think that this is not 1, this is 0.5, okay, so আমরা যদি এখন অ্যাড করতাম, this is 1, this is -0.5, so we will get a wave, but the amplitude is lower. Amplitude is lower. This is 1, this is -0.5, so we will get ultimately 0.5 amplitude. We will get a wave, and the amplitude of this wave is 0.5. We will get this type of scenario. So this is actually the call of standing wave, as you see here, picture of standing wave. One wave, the direction is totally opposite. So these types of waves are standing wave. Now we will read some properties of longitudinal wave. The particle of the medium vibrates simple harmonically along the direction of the propagation. Now you all have the idea about what is simple harmonic motion, and in your today's exam all the questions is related to this simple harmonic motion. So you have a solid idea about what is the simple harmonic motion. All the particles have the same amplitude, frequency, and time period. So as you see in my slide that all the particles need to be same amplitude, frequency, and time period. There is a gradual phase difference between the successive particle. All the particles vibrating in a phase will be at distance equal to, and it means the minimum distance to the wavelength. So these are some properties of the longitudinal wave. And now we will, as I already mentioned, that progressive wave is really important for your incoming final exam. So we will derive an equation of progressive wave. And this is the graph of progressive wave. As you see in the graph is starting from 0, and this is the graph of a sine wave. And we know that one wavelength is here you see in the slide that one wavelength is lambda, and the particle at any position of particle p is x, and the wave is propagating in positive x with a velocity of v. So we know that this type of progressive wave solution, this is a simple harmonic motion, and we know that the solution of simple harmonic motion is equals to y is equals to a sine omega t, where a is the amplitude, omega is the angular frequency, and t is the time. আমরা যদি এই পজিশনে পার্টিকেলটার মুভমেন্ট ক্যালকুলেট করতে চাই, so we will calculate all these things. And if you have some sort of phase difference, initial phase difference, if you don't start from zero, then if you have some sort of phase, so there, this is actually the phase. Let's think about that. You will start from this point P. আমাদের এই P পয়েন্টের কি phase zero? No, this is not zero. If we start from so there is some sort of point, so phase, so আমাদের সেই phase-টা কিন্তু subtract করতে হবে, and we already discussed about this types of equation. Now আমাদের phase-টা যদি আমরা calculate করতে চাই, আমাদের এই পয়েন্টের phase-টাকে যদি আমরা আলফা দিয়ে ডিনোট করি এবং কতটুকু ডিসটেন্স ট্রাভেল করার পরে এই phase-টা হয়েছে x ডিসটেন্স ট্রাভেল করার পরে, so if we take a ratio of this phase angle and this distance, so we will get the similar answer. The distance between these 2 points is lambda. This is a full wavelength, and in this full wavelength the phase change is twice. So if we take the ratio again, we will find the same ratio all the time, because this is a progressive wave, and in a progressive wave রেশিও গুলো সব জায়গাতে কি হবে, ইকুয়াল হবে, রাইট? বুঝতে পারছেন সবাই?
Yes, sir.
So then you will find out the value of alpha from here. That means twice pi by lambda into x. That means আমাদের যে কোনো পয়েন্টের ফেজটাকে আমরা নাও ক্যালকুলেট করতে পারবো। আমরা যদি ডিসটেন্সটা জানি যে কতটুকু ডিসটেন্স ট্রাভেল করেছে, সেই ডিসটেন্সটা যদি if we know that, then we can easily find out any যে কোনো পজিশনের আমরা কিটা ফেজটাকে ক্যালকুলেট করতে, ফেজ ডিফারেন্সটাকে ক্যালকুলেট করতে পারবো। And we have the idea about the angular frequency is twice pi by t, and we know that if 1 by t means what? 1 by t means f, and you know that f is equals to nu by 1 by t means, okay, here you see that we know that as if I write down these things in the whiteboard. Okay, so I want to omit. Okay, now you know that omega is equals to what? Twice pi nu. You know that these things, so you can ultimately write down these things. Okay, so you can ultimately write down twice pi. Nu means frequency, means velocity, by wavelength. You know these things. So omega, angular frequency, is twice pi v by lambda. So you can find out these things, and you know all these things from our previous classes. So we can write down omega is equal to twice pi v by lambda. This is v, velocity. So now we can put all these values in our equation number 2. That means if you put the value of omega, that means twice pi vt by lambda, minus alpha means twice pi x by lambda. If you put all these values, you can ultimately find out the equation of progressive wave. That means a sine twice pi by lambda vt minus x, and this wave is propagating through positive x direction. So this is the equation when wave is propagating in positive x direction. If the wave is propagated in the opposite direction, that means negative x direction, there will be a plus sign here. Okay, so these types of thing will be present. So if the wave is propagating in negative x direction, as you see in my slide, our equation will change, and the change will be positive. So now we will find out the differential equation of wave motion. Now we have this solution. We have this equation of progressive wave. If you differentiate these things, like with respect to t, you will get sine will be like cos twice pi by lambda, vt minus x. So if you derivate this with respect to t, v will be out here, so this is twice by ab by lambda cos twice these things. Now if you differentiate these things with respect to t again, so you will get this constant term out of again, so you will and if you differentiate the cos part, you will get a minus sign, so this is the minus. So ultimately you will find this equation as you see in my slide. So if you differentiate this equation of 7 with respect to t, now if you differentiate the equation number 7 dependent on t and x, so if you differentiate this with respect to x, now sine will be like equation number 6, your sine will be like cos, but here is a minus sign present in front of x again. So this is, if you differentiate these things for once, you will get twice pi by lambda outer, because this is multiplied to this x. I think you understand these types of differentiation because you were really familiar with this type of things, right?
Yes, sir.
Okay, so if you differentiate these things again with respect to x, you will get a minus sign for cos, you will get a minus sign cos to sine, so differentiate you will get a minus sign, and here minus sign already present, so minus and minus will be plus here, so you will get ultimately see that your first derivative with respect to t is this
ওখানে x এর জন্য আরেকটা মাইনাস হবে না?
Okay.
মাইনাস x এর জন্য
Yes, minus. Okay. একটা minus আসবে cos to sine আর একটা minus. Yes, there is a mistake in my slide. Okay, thank you. There is another minus sign will be present in this equation number 11. So now if you the solution differentiate with respect to t for once, and the solution differentiate with respect to x once, all the things are similar, expect the view, expect this v, so we can write down this equation number 8 and equation number 10 like this fashion. That means dy by dt is equals to minus v dy by dx, right?
Right.
There is no minus sign in equation number 8, but there is a minus sign in equation number 10, so there will be a minus. There is no v in equation, there is a v in equation number 8, but there is no v in equation number 10, so this is v. So this type of things will happen. So this is your equation number 12, and as you see here again, that equation number 9 and equation number 12, all these things are similar, like this. All these things are similar, right? Equation number 9 and equation number 11. Okay, there I think there is some sort of mistake is present here. If you derivate these things, there will be a minus sign, and this will be like 4 pi squared. Yes, this is 4 pi square. So all these things will be similar, expect this v square. So you will get ultimately the final answer, equation number 13. That means d square y by dt square equal to v square d square y by dx square, right? So এখানে কিন্তু ইকুয়েশন নাম্বার 11 এ একটা মিস্টেক আছে। আপনারা যখন বাই হ্যান্ড ক্যালকুলেশন করবেন তখন দেখবেন ইকুয়েশন নাম্বার 10 কে আরেকবার ডিফারেন্সিয়েট উইথ রেসপেক্ট টু x করলে ইউ উইল গেট 4 pi squared a by lambda square sine twice pi by lambda vt minus x. So if you compare this equation with equation number 9, you will get this solution, and this is called the differential equation of wave motion. So if you see the question like this, find out the differential equation of wave motion, you will get this answer. আপনারা এই পর্যন্ত লিখবেন, বুঝতে পেরেছেন? Starting from here, for 2 times and differentiate with respect to x for 2 times, then you will get your equation of wave motion. So now our next target is to find out you will find the energy of progressive wave. Now we have the equation of progressive wave something like this fashion. So what is the energy? If we find out the total energy means kinetic energy plus potential energy. So the particle, if the particle velocity is u, we can write down the particle velocity like dy by dt, because velocity means the position divided by time. T for once, you will get the particle velocity u, and you will get the acceleration if you differentiate these things again with respect to t. Okay, so you will get this answer, and if you put the value of y, because you know that a sine twice phi by lambda vt minus x means y, so if you put this value here, you will ultimately find out the acceleration. Now our target is to find out the energy. In case of energy calculation, we need 2 energy. First one is potential energy and second one is kinetic energy. So if you find out the potential energy, you know that energy and work done is pretty similar, and you know that work done is like F force into displacement. So this is the work done like dw, because to find out the work done per unit volume, then you need to divide this work by volume. So this is the work done per unit volume. So dw by v, and you know that what f is equals to means what? F means ma. So if you put this value here, m a dy divided by v, and you know that the value of mv means rho, so you can ultimately find out rho a dy. So dw means what? You have the idea about a in the equation number 16. So if you put the value of a here, you will ultimately find out the dw like the equation number 17. So if you find the total potential energy, you need to integrate all the whole things. So your integration is dependent on y. So all these things are constant, so all these things are out of your integration. Only y is remaining, and y, and the integration of y dy means y square by 2. And if you put the limit, you can ultimately find out this solution. And you know the value of y means a sine twice pi by lambda vt minus x. So if you put the value of y here, so you will find out the potential energy per unit volume. This is the potential energy per unit volume. This is equation number 18. Your next target is to find out what? Find out the kinetic energy. And you know that the kinetic energy means half m into what? Velocity square. And you know that we denote the velocity with u. So this is u square, and here we want to find out the kinetic energy per unit volume. That means half mv square. So if I write this half mv square, this v is velocity, divided by, if we want to find out these things for per unit volume, divided by volume. Here m by v means what? M by v means what?
Density.
This is density. So this is our equation like rho v square. Now if you put the value of rho here, you know that the value of u is equals to like twice pi a v by lambda cos twice pi by lambda vt minus x. So if you put the value of u here, you will ultimately find out the kinetic energy per unit volume, and the equation will be looks like the equation number 19. So our target is to find out the total energy per unit volume, and you know that the total energy per is kinetic energy per unit volume. So if you put this potential energy and kinetic energy here, you will ultimately find out this solution, and you know that sine square theta plus cos square theta means 1. So you will ultimately find out the total energy, something like this fashion, equation number 20, right?
Yes, sir.
So now again, you know that v means frequency into lambda. If we denote the frequency with respect to n, so we can write down v is equals to n lambda. So we can write down v square is equals to n square lambda square. So lambda square in the denominator and lambda square in the numerator will be cut down, and our equation will be something like twice pi square a square n square rho, where rho is the density, n is the frequency, a is the amplitude, and this is pi, and 2 is constant. So this is the kinetic energy. So this is the total energy per unit volume. Okay, I think you understand these things. If you have any question, you can ask me. Feel free to ask any question. আপনারা বুঝতে পেরেছেন সবাই?
স্যার এই ইকুয়েশন গুলো কি মানে পরীক্ষায় আসতে পারে? 24-25 ইকুয়েশন প্রমাণ করতে হবে?
Yes, পরীক্ষায় আসতে পারে. Find out the total energy per unit volume.
ম্যাথ আসতে পারে?
Yes, আসতে পারে.
স্যার মানে কয় নাম্বারের জন্য আসতে পারে?
এই প্রুফটা দিলে আপনাদের 15 মার্কসের এই প্রুফটা থাকবে। যদি এই প্রুফটা এক্সামে দেওয়া হয়, লাইক ফাইন্ড আউট দ্য কাইনেটিক এনার্জি পার ইউনিট ভলিউম ইন কেস অফ প্রোগ্রেসিভ ওয়েভ, দেন এটা 15 মার্কসের একটা প্রুফ থাকবে। তারপরে ধরেন এই কোশ্চেনের সাথে থাকলো হোয়াট ইজ প্রোগ্রেসিভ ওয়েভ, রাইট ডাউন দ্য ক্যারেক্টারিস্টিক্স অফ প্রোগ্রেসিভ ওয়েভ। তো এখানে 5 নাম্বার, সো 15 আর 5 এ 20 গেল। আর আরেকটা থাকলো একটা ম্যাথ প্রবলেম, এই ফর্মুলা থেকে একটা ম্যাথ দিলাম, একটা ডেনসিটি দিয়ে দিলাম, ফ্রিকোয়েন্সি দিয়ে দিলাম, ফাইন্ড আউট দ্য টোটাল এনার্জি পার ইউনিট ভলিউম। সো ইফ ইউ জাস্ট পুট অল দিস ভ্যালুস ইন ইউর ইকুয়েশন and get your result, and you will get 10 marks for these types of math. বুঝতে পেরেছেন কোশ্চেনের প্যাটার্ন কি হবে ফাইনাল এক্সামে?
Yes, sir.
Things will be easy for you if you study, but if you don't study anything, you cannot write anything in the exam. If you study a little bit, study will make your result go up. Okay, so these types of things are now our we need a few more minutes for, then we will end up this lecture. Now this is the total energy per unit volume, then the average kinetic energy per unit volume, and the average potential energy per unit volume are equal. Now go back to this previous slides. Now this is the potential energy per unit volume, and this is the kinetic energy per unit volume. But if you think that the value of sine is what? The value of sine is 1 or the value of cos is 1, then you will get this solution like twice pi square v square a square rho by lambda square, and here is also similar, twice pi square v square a square rho by lambda square. So this kinetic energy and potential energy is pretty similar. If you find out that, just let that your potential energy and kinetic energy is equal, then you will find this energy pretty equal, and this is the average potential energy per unit volume will be like, if you divide this term by 2, then you will get the average, because this is the result of two things: kinetic energy plus potential energy. So if you take the average value, then you will just divide this value by 2 and you will find out the average kinetic energy or average potential energy, and your equation will be something like this fashion, like equation number 22 and 23. You understand these things?
Yes, sir.
Okay. So here is another line in this slide, that as the velocity of the wave is v, means the distance covered by the wave per second. So this is actually the means of wave. Velocity means the distance covered per second. So the energy transfer per unit area per second will be like this velocity. Now what? Now here is an important things. What is the unit here? Equation number 22 or 23. This is the energy, but per unit volume, right?
Joule per meter cube.
So if I want to, yes, not meter cube, yes, energy, that means joule, and this is per unit volume means meter cube. Okay, these things. Now if you multiply these things with velocity means meter per second. So this meter and this meter will be cut down. So this will be like energy per
Recording stopped.
দীপ্ত, এবার তুই শুরু কর।
প্লিজ দীপ্ত।
এ না ভাই থাক।
Average potential energy per
Okay. Let's go back to this. Go back here. Let's go back here. If I write down these two things here. Okay. Now, if I want to fit, then I need to divide this value by 2. Then I will find the average energy, right?
Yes, sir.
Okay, now think about that. Now go back here again. As you see in my slide, that the potential and equation of potential energy stays, and the equation of kinetic energy, all the things are similar, exist same. Here is sine and here is cos. If you let this value is the value of sine 90 is 1, the value of cos 0 is 1. So if you put these types of value, you will get this two answer. Or think about this fashion. When think about that average means what? Average মানে কি? আপনি দুইটা ভ্যালুর এভারেজ নিলেন, এটার মানে কি? ওই দুইটা ভ্যালুর মিডলে কোন একটা ভ্যালু পাবেন আপনি।
यस স্যার।
বুঝতে পারছেন আমার কথা স্টুডেন্টস? ওকে, সো আপনি যদি এটাকে এখানে এভারেজ করেন, দেন ইউ উইল গেট সাম ভ্যালু অফ এভারেজ এনার্জি, এন্ড দ্য ভ্যালু অফ এভারেজ এনার্জি উইল কোথায় থাকবে? মিডল, আইদার পটেনশিয়াল এনার্জি এবং কাইনেটিক এনার্জির মাঝখানের কোন একটা ভ্যালু হবে। সো আমরা বলছি যে আইদার ইট উইল বি পটেনশিয়াল এনার্জি, যখন আমরা এটাকে এভারেজ বলবো, আইদার ইট উইল বি পটেনশিয়াল potential energy বলেও কল করতে পারি, আর either it will be kinetic energy বলেও আমরা কি করতে পারি, কল করতে পারি ওটাকে। just this is the average energy per unit volume। বাট আমরা এটাকে কি বলতে পারি, যেহেতু আমরা পোটেনশিয়াল এবং কাইনেটিক দুইটা মিলে টোটাল এনার্জিটা পেয়েছি, সো এভারেজ নেওয়া মানে কি, either this is potential energy or this is kinetic energy। বুঝতে পেরেছেন?
Yes, sir.
Okay, anybody have any other questions? Okay,
আমার সিটি নিয়ে একটু সমস্যা ছিল স্যার।
হ্যাঁ বলতে পারেন।
স্যার আমি আজকে সিটি অ্যাটেন্ড করেছি স্যার, এন্ড আমার পিডিএফ ফাইলটাও সাবমিট করেছি, কিন্তু আমাকে পরে ইনফর্ম করা হয়েছে যে আমার ফাইলটা নাকি করাপ্টেড হয়ে গিয়েছে আর ফাইলটা নাকি রিড করা যাচ্ছে না স্যার।
আপনার রোল নাম্বার কত?
স্যার আমার রোল নাম্বার 9 স্যার, সেকশন বি।
আপনি আমাকে একটা মেইল দিয়ে রাখবেন যে আপনার রোল নাম্বার 9, আপনার এরকম এরকম প্রবলেম। ওকে, আমি আপনাকে মেইলে রিপ্লাই দিব আপনার স্ক্রিপ্ট আমি পেয়েছি কিনা।
স্যার আমি দিয়েছি স্যার।
ওকে, আমি ওটা চেক করে আপনাকে জানাবো।
ওকে স্যার।
ওকে, ঠিক আছে। সো নাও আই এম গোইং ব্যাক টু দ্য ইনকাম ফর add your attendance
আমাদের সিটি 2 তে কি এই টপিকটা থাকবে?
সিটি 2 তো হয়ে গেল, সিটি 3 তে
সরি
থাকবে। হ্যাঁ হ্যাঁ